Basically, it is all stone with the exception of obsidian and coal are made of minerals. So obsidian is a volcanic stone made of glass and the coal is made of natural carbon. Mostly of the rocks contains a few minerals and a blend normal for a specific stone sort. So while distinguishing stone, you should initially recognize the individual minerals that make up the stones. So minerals are normally happening in organic solids with positive compounds organization and a precious stone grid structures or crystal structures in spite of the fact that a large number of minerals in the earth have been distinguished. Only 10 minerals make up the vast majority of the volume of the world. Minerals can be distinguished by their physical qualities. The physical properties of minerals are identified with their substance, structures, and holdings. A few attributes like mineral hardness are more valuable for mineral recognizable proof. Color is promptly discernible and positively self-evident, yet it is not less dependable than the other physical properties. By the help of mineralogists or researchers who study minerals, something mineralogists should do is to distinguish and classify minerals. While the mineralogists may utilize the power of magnifying lens to distinguish a few minerals, most are unmistakable utilizing physical properties. Basically, physical properties of minerals address simply one or more intricate construction in this enormously fluctuated Earth. There are unlimited measures of studies that can be covered when managing the subjects of Minerals exemplify various actual properties or physical properties which makes them considerably more intriguing and complex than usually thought. A few of these properties are fundamental in minerals distinguishing proof. With enough experience, a mineral can be regularly be precise, distinguished by physically seeing it. Notwithstanding by leading a couple of straightforward tests, the distinguishing proof method is precise and undeniable. So researchers recognize essential cosmetics by leading the complex tests with costly gear like X-rays and powerful electron magnifying lens. They utilize this method to distinguish minerals. And generally, however, minerals can be recognized by directing a couple of basic costless tests. When individuals become experienced in this field, he can typically recognize a mineral by noticing it or seeing it, and considering it is a particular components like the color and the crystal stone development or structures. So color, streak, and luster. So precious stones such as diamonds are famous gemstones in the ground that the manner in which they mirror light makes them shimmer. Turquoise or turquoise is valued for its striking greenish blue tone. Notice that the particular terms are being utilized to portray the presence of the minerals. So what is color? Color is frequently helpful yet ought not to be dependent upon. Various minerals might be similar shading, for example. Genuine gold, as found in the figure 2, is basically the same in the shading of pyrite in figure 1. Also, some minerals may come in various shadings, like quartz, for instance, may be clear, white, brown, dark pink, yellow, orange, and even red. Therefore, shading can help, but however, don't depend on shading or color as deciding property. So, luster depicts the impression of light of a mineral surface. Mineralogists have extraordinary terms to portray luster. One basic approach to order luster depends on whether a mineral is metallic or non-metallic. Minerals that are misty and sparkly like pyrite have a metallic luster. Minerals, for example, quartz, have non-metallic luster. Luster is the means by which outside of minerals mirrors light. It isn't exactly the same thing of color. So it's essential to recognize a luster from color. For instance, a mineral depicts a sparkly yellow. It's being portrayed as far as luster or shiny and shading is yellow, in which two distinct actual properties. Standard names for radiance incorporate metallic, smooth, and magnificent. Flush, oily, and dull. It is valuable to initially decide whether a mineral is metallic luster. A metallic radiance implies luster like clean metal. For instance, clean beads chrome, steel, titanium, copper, and metal, and all display metallic brilliance as do numerously different minerals. Of the non-metallic, shines polish is the most widely recognized implies in the outside of the mineral mirrors like glass. Magnificent radiance is significant in distinguishing the feldspar, which are most widely recognized in kind of minerals. Magnificent shines alludes to unconscious iridescence or color plays mirrored light, the same way pearls mirror light. And also, oily shines seem to like luster of hardened bacon oil, and mineral with dull shine mirror next to the light. Recognizing radiance takes to practice. Make sure to recognize shine or luster from color. So, the streak is a shade of color of mineral powder. Streak is more dependable property than coloring since streak doesn't shift. Minerals are the similar color might have alternate hued streak. Almost every mineral has innate streak tone regardless the shading and the genuine material is. For instance, calcite happens in a wide range of color shapes and assortments. In any case, each of the very assortment of calcite has white streak. Streak is valuable in separating two minerals with the same color and unique streak. So, most light-hued non-metallic minerals have a white dismal streak, as do most silicate, carbonates, and most straightforward minerals. Streak is generally valuable for distinguishing dull-hued minerals, particularly the metals. Hardness assumes a significant part in distinguishing a mineral. It can make identification process a lot easier by significantly narrowing a search. Hardness is a strength in which mineral opposes to its surface being scratched or penetrated. In working with a hand test with a particular instrument, mineral hardness is determined by Mohs hardness scale. To think about it, the hardness of two minerals see which minerals start to expose the other. With Mohs scales, anybody can test it obscure mineral for its hardness. Envision you to have obscure minerals. You find it you scratch fluorite or with a even feldspar. You realize that the mineral's hardness is somewhere in the range of 5 and 6. Note that no other mineral can scratch jewels. So the next one is the cleavage. So basically the cleavage is the prosperity of a mineral to fracture along the specific planes to make a smooth surfaces. Highlight fractures between layer of sodium and chlorine to shape blocks with a smooth surfaces, as we can see in the picture here. So it is a nearby perspective of sodium chloride in a water bubble at a Board International Space Station. So typically a mineral that normally fractures into completely level surfaces is displaying cleavage. Not all minerals have a cleavage. So a cleavage addresses a heading of shortcoming in the precious stone cross section. So cleavage surfaces can be recognized by how they reliably mirror light as though clean, smooth, and even. The cleavage properties of minerals are depicted as far as the quantity of cleavage, and if more than one cleavage, the points between the cleavages. So, the quantity of the cleavage is the number of headings where the mineral servers. A mineral might show 100 cleavage surfaces corresponding to one another. Those addresses a solitary cleavage in a light fact that the surfaces are completely situated in similar directions. The considerable number of cleavages mineral might have 1, 2, 3, or 6 in an event more than one cleavage is available and a gadget for estimating point isn't accessible. Essentially, the state of cleavage made 90 degrees to see a mineral cleavage hold the mineral up underneath the solid and the light fracturing. A mineral fracture is compound bonds. Since certain bonds are fragile than the different bonds, it's sort a mineral probably is going to the fracture. And consequently, minerals falls into pieces characteristically. Mica has a cleavage in a way of structure sheets. So, minerals can be separated into polygons, fluorite structures. And as we can see here in the picture, a rough diamond on its orthogonal cleavage. One explanation gemstone is so lovely is that the cleavage planes make alluring a precious stone. Fracture is a fracture in the mineral that isn't along the cleavage plane. Fracture is in general something similar or in a similar mineral in the grounds that a fracture isn't controlled by the design of the minerals. So minerals might have trademark fractures. Metals typically fracture into spiked edges in the event that minerals splinters like wood. It could be sinewy. A few minerals like quartz structures a smooth bended surface when they fracture. So all minerals have fractures. Fractures is breakage where which happens in the heading that are not cleavage bearings. A few minerals like quartz have no cleavage at all. At the point when the minerals with no cleavage, it is fallen into pieces by sledge. It fractures in every which way. Quartz is said to conchodile fracture. Conchodile fracture is thick pieces of glass fractures conchodile. So, in any case, some quartz precious stones have such countless imperfections that opposed to showing conchoidal fracture, they essentially displayed as sporadic fracture. And also, the characteristic of the other fractures types. In initial geography, the key fractures type in Recolic are unpredictable, which most minerals display a conchoidal found that can be found in quartz. All minerals are translucent, however, just have a chance to display the shape of their crystals and the crystal structures. Numerous minerals in the basic topography lab don't show their crystal structure. So, on the off chance that a mineral has space while it develops, it might frame normal precious stones with a crystal shape mirroring the calculation of minerals in ward crystal grids. So, the state of crystals follows the balance of its precious stones across quartz. For example, structure six-sided gems. And there are two confusing variables to recollect here. Minerals first is minerals don't generally has a shape these as precious stones when they develop, and a crystal face is not quite the same as cleavage surface, and a crystal stone face structures during the development of minerals. A cleavage surface is framed when the minerals is broken. There are few properties that alone assistance to recognize few minerals, or even only solitary minerals. An illustration of particularly unique property is bubbly response of calcite to a frial arrangement of hydrochloric corrosive calcite bubbles where foams as HCI arrangements breaks down it makes CO2 gas. Calcite is not difficult to distinguish without even testing the response of HCI by its hardness, gloss, and cleavage. Other extraordinary properties is attraction. This can be tried checking whether a little magnet reacts to another minerals. And a unique property that appears in some examples of plagioclase feldspar is in the inclination to display saturation surfaces. Saturation are entirely significant straight lines. Next is the other unique properties may be experienced on mineral to mineral premise. A few minerals have other novel properties, which is are recorded in table 3 that I will show here. And also, it is probably found a super table. So it is a few minerals have uncommon properties that can be utilized for recognizable proof.